Welcome, stargazers. Could you believe it? Picture a divine event so huge that it creates shadows on Earth, visible even in broad daylight. That's the spectacle we might be on the verge of witnessing in the Orion constellation. The star Betelgeuse is acting mysteriously, hinting at an impending supernova explosion that could light up our sky like never before. But when will Betelgeuse go supernova? And what will it look like? According to scientists, what mysteries could this celestial event unveil? Join us as we dive deep into the details of what's really happening with Betelgeuse and the impact it could have on Earth, and perhaps even the entire solar system. Located roughly 650 light-years from Earth in the Orion constellation, Betelgeuse is not just any ordinary star. It's a red supergiant, one of the most luminous stars known to us, shining with a brightness more than 100,000 times that of our Sun. But why does this red giant matter so much to us? Well, Betelgeuse stands out not only for its brilliance, but also for its history and significance in human culture. Named after the Arabic phrase, Yad al-Jawza, which means the hand of Orion, Betelgeuse has been observed and documented by ancient civilizations for centuries. It has been a guide for travelers and a point of wonder for stargazers, with its reddish hue distinguishing it from other stars in the Orion constellation. Can you imagine a single star dwarfing our entire solar system? To give some perspective on the sheer enormity of Betelgeuse, if it replaced our Sun, its edges would extend all the way to Jupiter. How could a single star ever achieve such colossal proportions? At 10 million years old, it's much younger than our 5-billion-year-old Sun. But Betelgeuse's massive size means it burns through its materials at a much faster speed, predicting a shorter lifespan than other stars. Now, the celestial behemoth, spanning a volume large enough to contain more than 1 billion of our suns, is nearing the end of its life cycle. When stars of such magnitude reach their twilight years, they don't just fade away. They go out with a bang, a supernova explosion that is beyond human comprehension in terms of its energy and brightness. Such an event has the potential to outshine an entire galaxy, casting shadows of brightness across vast cosmic distances. The last time Earth saw a supernova explosion this close was in 1604, long before the invention of modern telescopes. This event, known as the Kepler supernova, was the last supernova to be seen in our Milky Way galaxy with the naked eye, remaining visible for over 18 months. It was brighter than any other star in the night sky, and even stayed visible during the day for a few weeks. What secrets do these celestial remnants reveal to us? Ancient records from various civilizations, including Chinese and European astronomers, documented the appearance of this new star. Intriguingly, remnants of this explosion, in the form of an expanding debris cloud, can still be observed today with sophisticated telescopes, providing us insights into the violent ends of massive stars. Historically, supernovae have been rare observers on Earth, but imagine for a moment a stellar explosion, so intense that it rivals the brightness of a full moon, casting shadows on Earth at night and being visible during daylight. The radiation from such an event would charge our atmosphere, potentially affecting satellite operations and perhaps even the climate. Betelgeuse, with its erratic dimming patterns, suggests it might be gearing up for just such a grand spectacle. Could we be on the verge of witnessing one of the universe's most dramatic events? Recently, astronomers have made a startling discovery. Between October 2019 and mid-2023, Betelgeuse underwent a striking change that drew the attention of astronomers and enthusiasts worldwide. Known as the Great Dimming, the star's brightness, which had been consistent for centuries, began to diminish significantly. This sudden change was so noticeable that even casual stargazers observed it when comparing Betelgeuse to other stars in the Orion constellation. It implies that we're not just centuries away from witnessing its supernova explosion, but perhaps mere decades, or even less. By April 2023, astronomical observations reported that Betelgeuse had returned to its usual brightness levels, leading many to believe that the period of peculiarity had ended. In a surprising twist, the following months saw Betelgeuse's brightness increase by a staggering 50%. Such significant changes, while typical of variable stars, were unusual for a star like Betelgeuse, which had predominantly displayed predictable luminosity cycles. The sudden and intense surge in its brightness pushed the star back into the spotlight, reigniting discussions about its future. But what caused this sudden change in brightness? Why did Betelgeuse, one of the most familiar stars in our night sky, suddenly throw a cosmic curveball? Stars are not just twinkling dots in our night sky. They are dynamic entities, constantly evolving, and Betelgeuse is showing us just how active the universe can be. With life cycles, exercises, and secrets of their own, some heavenly bodies' occasional brilliance varieties can be expected, similar to the rhythms of Earth's seasons all through its heavenly lifetime. Creepy Crawly Jew has kept a genuinely consistent 400-day radiant cycle. Anyway, with the extraordinary darkening, it appeared to challenge its laid-out conduct, testing our perception of the heavenly peculiarities above. Now, you may be pondering, are we nearly a heavenly disclosure? While the specific purposes behind Scarab Jew's inconsistencies are still under examination, a compelling hypothesis has arisen. This hypothesis, zeroing in on heavenly activity and mass launch, presents a charming scenario. Picture Bug Jew as a giant heavenly fountain of liquid magma, inconspicuously emitting and ousting a huge measure of its matter into space. Past perceptions from the Hubble Space Telescope revealed that Scarab Jew had recently removed a gigantic sum of its surface material into the universe. This removal, a fantastic event, was 400 billion times the mass typically released during similar solar phenomena, comparable to several times the mass of our moon. Such events can result in the development of a thick dust cloud around the star, affecting its apparent brightness and briefly making it more challenging to observe. Then, as this dust began to scatter or was pushed away by the force of the star's radiation pressure, the cloak lifted. This could explain its subsequent return to customary brilliance levels. One way or the other, these new events suggest a star that is not done amazing us. Many guess that Jew may be approaching the twilight of its life, a supernova event, a staggering explosion of energy that can outshine an entire galaxy instantly. This phenomenon occurs when there is an unexpected change in the star's core. Such changes can arise if a star absorbs too much matter from an adjoining star, or in Bug's case, it could be from the exhaustion of its nuclear fuel, which fountains its mass into the core, setting the stage for a catastrophic collapse. But what drives a massive star like Betelgeuse to its end? Born from the gravitational collapse of gas inside molecular clouds, stars like Betelgeuse launch their journey by burning hydrogen in their cores. This starting point, known as the main sequence stage, lasts for millions of years and forms the backbone of a star's life. However, as stars run short on hydrogen, they expand, embracing new energy sources. In the case of Bug Jew, as the hydrogen depletes, it begins to burn helium, leading to the formation of carbon and oxygen. This transition from the main sequence stage to the helium burning stage is marked by the star's journey into a red giant. With time, as helium reserves dwindle, the star undergoes further development and shifts into other burning stages, each characterized by the fusion of progressively heavier elements. The bigger the star, the quicker these changes occur, given the massive gravitational pressures at play. Then comes the climax, when iron begins forming at the core. Unlike lighter elements, iron doesn't release energy when fused, so the energy produced isn't enough to resist the star's own crushing gravity. The star balloons in size and collapses, followed by a massive rebound effect, resulting in the explosive force of a supernova. So, is Scarab Jew near the edge of a dramatic end, or simply biding its time? Later research by Japan's Tohoku University suggests that the star might be in its carbon-burning stage right now. Lead researcher Haddock believes that the core could collapse decades after its carbon reserves deplete. Yet not all scientists agree. Contrasting studies from Hungary's Konkoly Observatory speculate that Scarab Jew is still in the earlier helium-burning stage. The one thing that scientists do agree on, regardless of these debates, is that Betelgeuse is scheduled to become the Milky Way's next supernova. But pinpointing the timing of this event remains a cosmic guessing game, with predictions ranging from just a few decades to 100,000 years. Amidst these scientific debates and theories about Bug Jew's destiny, one truth stays unchallenged: the actual idea of our perceptions, when we gaze toward the brilliant territory, reveals an inconspicuous mystery we frequently disregard. This paradox is established in the actual nature of time and light in our vast universe. Stars and celestial bodies are so far off that their light takes a great measure of time to reach our eyes. For example, the speed of light, while being a staggering 186,282 meters per second, actually has its limitations. Thus, the light from distant stars and galaxies takes its time to cross the immensity of space before it graces our sight. Looking at Betelgeuse, you're actually seeing a spectacle from 650 years in the past. To put that in context, when this very light left on its journey toward Earth, the Renaissance was just unfolding, and explorers like Marco Polo were making their mark in history. Every observation we make of Betelgeuse is like looking through a vast time capsule, giving us insights into its distant past. If, for argument's sake, Betelgeuse had already exploded in a spectacular supernova, we would remain unaware for another 650 years. So, while we examine and anticipate its looming supernova, somewhere out in the vast universe, this amazing event may have already unfolded. We're just waiting for it to navigate space and time until it reaches our eager telescopes. The recent discoveries around Betelgeuse have led to intense discussions in the astronomical community, with comparisons being drawn to another shocking revelation from earlier this year, SN 2023X. This recently observed supernova, happening in a galaxy neighboring the Milky Way, reminded many of the intriguing dynamics and unpredictable nature of the universe. SN 2023X was remarkable in its own right. Located several million light-years away, it exhibited a spectacular display of brilliance that briefly outshone its host galaxy. However, what made it especially intriguing to scientists and casual observers alike was its uncanny resemblance to what many expect will be the fate of Betelgeuse. The range, power, and aftermath of the explosion offered a tantalizing glimpse into the processes that these massive stars go through as they approach the end of their life cycles. For many, SN 2023X served as a preview of what might happen if and when Betelgeuse meets its explosive fate. The sequence of events might resemble what was seen with SN 2023X. The connection between these two celestial events highlights a broader theme about the interconnectedness of our universe. Whether it's a neighboring star like Betelgeuse or a distant supernova like SN 2023X, these cosmic phenomena remind us of the dynamic and evolving nature of space. Beyond the tangible and scientific, the explosion would have profound impacts on human culture. The sky, observed and revered for centuries, would change, prompting reflections on transience, the vast scales of cosmic time, and our position in the universe. Such cosmic wonders remind us of the ephemerality of existence and our eternal quest to comprehend the incredible past. As we contemplate the potential supernova of Betelgeuse, it's essential to understand the broader implications of such an event on our cosmic neighborhood. When Betelgeuse finally reaches its explosive end, it could impact not only our immediate area in the Milky Way, but also the dynamics of the interstellar medium. The shock waves generated by the supernova will create vast regions of ionized gas, enriching the surrounding space with heavier elements forged during the star's life cycle. This process plays a vital role in the cosmic cycle of matter, seeding new stars and planets with the essential elements for life. In addition, the light from the looming explosion could serve as a stellar laboratory for astronomers. Observing the light curve and spectral features of the supernova could provide invaluable data on the life and death of massive stars. Each supernova offers a unique glimpse into the physical processes at play, revealing how energy is distributed in such catastrophic events. By studying these phenomena, scientists can refine their models of stellar evolution, contributing to our understanding of the universe's life cycle. Beyond scientific advancements, a supernova can have cultural repercussions. Historically, significant cosmic events have impacted art, literature, and philosophy. The brilliant appearance of Betelgeuse would likely inspire a new wave of creative expression and reflection. People across the globe would look at the night sky, contemplating their place in the universe. This event could foster a renewed interest in astronomy and science, much like the curiosity that arose during the Renaissance, when celestial observations began to reshape our understanding of the universe. From a practical standpoint, the effects of a supernova could extend to technology. Increased radiation levels from such an explosion could pose challenges for satellite communications and navigation systems. These implications would require advancements in shielding and protective technologies, further pushing the boundaries of engineering and space exploration. As we continue to rely more heavily on technology, understanding these cosmic events becomes crucial for mitigating their impacts on our daily lives. The supernova could also change our perspective on time itself. The fleeting nature of such an event reminds us that even the most giant celestial bodies are not eternal. This realization might prompt philosophical discussions about existence and the transient nature of life. The universe operates on time scales that dwarf human lifespans, yet we find meaning in our brief moments under the stars.